Transmission Control Protocol accepts data from a data stream, segments it into chunks, and adds a TCP header, creating a TCP segment. The TCP segment is then encapsulated into an Internet Protocol datagram. A TCP segment is the packet of information that TCP uses to exchange data with its peers. The term TCP packet, though sometimes informally used, is not in line with current terminology, where segment refers to the TCP PDU. It's a datagram. It's a PDU stands for Packet Datagram Unit. Processes transmit data by calling on the TCP and passing buffers of data as arguments. The TCP packages the data from these buffers into segments and calls on the Internet module to transmit each segment to the destination TCP. A TCP segment consists of segment header and the data section. The TCP header contains 10 mandatory fields and an optional extension field. The data section follows the header. Its contents are the payload, data carried for the application. The length of the data section is not specified in the TCP segment header. It can be calculated by subtracting the combined length of the TCP header and the encapsulating IP header from the total IP datagram length specified in the IP header. The source port in the segment in a TCP IP header has 16 bits and identifies the sending port. The destination port also has 16 bits and identifies the receiving port. Sequence number has 32 bits and has a dual role. The first role: if the scene flag is set 1, as you can see, the scene has a flag, separated flag. If the scene flag is set 1, then this is the initial sequence number, the sequence number of the actual first data byte, and the acknowledged number of the corresponding ACK are then this sequence number plus 1. The role 2, situation 2. If the scene flag is clear or 0, then this is the accumulated sequence number of the first data byte of this segment for the current session. Acknowledgement number has the 32 bits. If the acknowledgement flag is set, then the value of this field is the next sequence number that the receiver is expecting. This acknowledges receipt of all prior bytes, if any existing. The first acknowledge sent by each and acknowledgements of the other ends initial sequence number itself, but no data. Data offset 4 bits specifies the size of the TCP header in 32-bit words. The minimum size header is 5 words and the maximum is 15 words, thus giving the minimum size of 20 bytes and maximum of 60 bytes, allowing for up to 40 bytes of options in the header. This field gets its name from the fact that it is also the offset from the start of the TCP segment to the actual data. Reserved. For reserved, there are reserved 3 bits, which are reserved for future use and should be set to 0 in normal mode. Flags has 9 bits, or they can be opened as a control bits. Contains 9 1-bit flags. So they are: first bit NS, ECN nonce concealment protection, added by header. CWR, congestion window reduced, flag is set by the sending host to indicate that it received a TCP segment with a ECE flag set and had responded in congestion control mechanism. ECE, it's a ECN echo indicates. If the SYN flag is set 0, that the TCP packet with congestion experienced flag in IP header set is received during normal transmission. If the SYN flag set to 1, the TCP peer is ECN capable. URG indicates that the urgent pointer field is significant. ACK indicates that acknowledgement field is significant. All packets after the initial SYN packet sent by the client should have this flag set. PSH, push function, asks to push the buffered data to the receiving application. RST, reset the connection. SYN, synchronized sequence number. Only the first packet sent from each end should have this flag set. Some other flags change meaning based on this flag, and some are only valid for when it is set, and others when it is clear. And finally, FIN. It means no more data from sender. Another octet of the TCP segment is window size, which has 16 bits, the size of the receive window, which specifies the number of window size units by default that the sender of the segment is currently willing to receive. Checksum has 16 bits. The 16-bit checksum field is used for error checking of the header and data. Urgent pointer has 16 bits. If the URG flag is set, then this 16-bit field is an offset from the sequence number indicating the last urgent data byte. Options. It's a variable from 0 to 320 bits, divisible by 32. It is the length of the field is determined by the data offset field. Options have up to 3 fields. Option kind 1 byte, option length 1 byte, option data variable. The option kind field indicates the type of option and is the only field that is not optional. Depending on what kind of option we are dealing with, the next two fields may be set. The option length field indicates the total length of the option, and the option data field contains the value of the option if applicable. For example, an option kind byte of 0x01 indicates that this is a no optional option used only for padding and does not have an option length or option data bytes following it. An option kind byte of 0 is the end of option and is also only one byte. There were so many options there, so let's go next. Padding. The TCP header padding is used to ensure that the TCP header ends and data begins on a 32 bits boundary. The padding is composed of zeros. Some options may only be sent when SYN is set. They are indicated below. 0, it's end of option list. 1, no operation. 2, 4, maximum segment size. 3, 3s, window scale. 4, 2, selective acknowledgement permitted. 8, 10, quad T, quad E, timestamp and echo of previous timestamp. 14, 3s, TCP alternate checksum request. 15, n, variable bits and TCP alternate checksum data. TCP protocol operations may be divided into three phases. Connections must be properly established in a multi-step handshake process, connection establishment, before entering the data transfer phase. After data transmission is completed, the connection termination closes established virtual circuits and releases all allocated resources. A TCP connection is managed by an operating system through a programming interface that represents the local endpoint for communication, the Internet socket. During the lifetime of a TCP connection, the local endpoint undergoes a series of state changes. So they are: listen. Listen represents waiting for a connection request from any remote TCP and port. SYN sent. It's usually doing by a client. Represents waiting for a matching connection request after having sent a connection request. Server. SYN received represents waiting for a confirming connection request acknowledgement after having both received and sent a connection request. Established. And it is available in both server and a client. This represents an open connection. Data received can be delivered to the user. The normal state for the data transfer phase of the connection. FIN wait 1. It could be done by both server and client. Represents waiting for a connection termination request from the remote TCP or an acknowledgement of the connection termination request previously sent. FIN wait 2. It's available both for server and a client. Represents waiting for connection termination request from the remote TCP. Close wait. This available for server and client, which is represents waiting for connection termination request from the local user. Closing. Both for server and clients are available. Represents waiting for a connection termination request acknowledgement from the remote TCP. Last ACK. Both server and client could have this state. ACK state represents waiting for an acknowledgement of the connection termination request previously sent to the remote TCP. It could include an acknowledgement of its connection termination request. Time wait represents waiting for enough time to pass to be sure the remote TCP received the acknowledgement of its connection termination request. And finally closed, it represents no connection state at all.